Formally, once again, Assalamu alaikum. How is everyone? Let's see what are we going to do today. Okay, so let's begin. So it's your fourth online class of this session. So what is the purpose of today's class? Very brief revision as usual, and then numericals. So what have we done? We have done few problems yesterday and day before yesterday. Recall your memories. A cyclist was there going up. What was the speed? 3.5 meter per second. What was the slope? 30 degree. He stopped paddling. That is why the final velocity is 0. Since the cyclist is going up, that is why the negative sign is there with 9.8. And we have to find the distance before it coming to rest. To find distance, we need acceleration. So we will find first acceleration by using the formula A is equal to G sine theta. Substituting the values, and we got the result A is equal to minus 4.9 meter per second square. After that, we use the formula third equation of motion, 2as is equal to vf square minus vi square, right? Then we change it to distance, as you can see on the screen, substituting the values, and we got the same. Okay, the result is there in front of you, 1.25 meter. The same sort of question, we did another one, only the data is more or less like the same. Instead of a cyclist, we have a car which is moving with a velocity of 63 km per hour. And what is the slope? 45 degrees is the slope. We converted 63 km per hour into meter per second by multiplying it 1000 divided by 3600. The car stops. That is why its final velocity is 0. Again, we have to find the distance over here. In the same way, we found the acceleration first, used this formula, substitute the values, and got the result. Clear? Then we did another problem. The same car, the same speed, the same slope, but this time, what is there? The frictional force is there. And the weight of the car is also given, right? So in this case, we'll find the acceleration, but with a little bit different formula, right? So first we convert weight into mass. You know that W is equal to mg. Changing it, it will become M is equal to W upon G. Substituting the values, we got the mass 2000 kilogram. Then for acceleration, we use the formula A is equal to G sine theta minus F upon M. Why are we using this formula? Because in the question, it's mentioned there, the frictional force. That is why we'll use this formula. If the frictional force is 0, then we use the simpler formula. Substituting the values, simplifying it, the acceleration you can see on the screen. We calculated minus 7.928 rather. Then in the same way, we found the distance of the car before coming to rest, 19.31 meter. So these were the three problems related with inclined plane. Then we did what? A problem related with momentum. That there is a 100-gram bullet which is fired from a 10-kilogram gun. Initially, both of these were at rest, so their initial velocities are 0. When the bullet is fired, its velocity, it acquires the velocity of 1000 meter per second. As you know that if the bullet is going in the forward direction, the gun will go in the backward direction. This is called the recoil of the gun, and we have to find the velocity of the recoil of the gun, right? So here is the data. Mass of the bullet, 100 gram, we convert it into kilogram divided by 1000. It's your revision, right? M2, 10 kilogram. Initial velocity of bullet and the gun, 0. Final velocity of the bullet, 1000 meter per second, and we have to calculate the final velocity of the gun, of the recoil of the gun rather. Simple. We, according to the law of conservation of momentum, m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. We substitute the values. 0.1 multiplied by 0 will become 0. 10 multiplied by 0 will become 0. Adding the zeros will give you this simplified form. Change their sides. 100 would be transferred on the right side. Then multiply by 10 would be transferred to the right side as division. Okay, so we got the answer minus 10. Negative sign shows the gun is going in the backward direction, right? So today we are going to do another problem related with the momentum, and you can see the screen. A machine gun is there. Machine gun can fire more than one bullet per second. So this machine gun can fire just 10 bullets per second. Means in 1 second it can fire 10 bullets, right? And what is the mass of each bullet? 20 gram. Okay. What is the mass of each bullet? 20 gram. So in 1 second, 10 bullets are coming out. So what is the total mass of these 10 bullets? 20 multiplied by 10, 200 gram. So in 1 second, around 200 gram of bullets are coming out. We will convert this gram into kg, right? And another thing is given, speed. The speed of each and every bullet is same. What is the speed over here? 1500 meter per second. Okay, and what is the task here? That we are asked to find the value of the force to hold the machine gun. Since the bullets are moving in the forward direction, the machine gun will apply some force in the backward direction. So you must need some force to hold the gun, to hold the machine gun in a position. So we have to find that, right? So this force is equal to the momentum of the bullets, because bullets are going in the forward direction. Momentum of the bullet means the mass of the bullet, the velocity of the bullet. All right. So let's see. What is the data over here? Rate of firing of bullets. In 1 second, the machine gun is firing 10 bullets. Mass of each bullet is 20 gram. Initial speed of each bullet, they were at rest, 0 meter per second. Final speed of each bullet, 1500 meter per second. Time, the scenario is focusing on per second, 10 bullets per second. So what is the time here? The time is 1 second. Okay, and what is the question? What is the task here? We will find the value of the force. Clear? machine gun firing 10 bullets per second. Mass of each bullet is 20 gram. The speed is 1500 final is the final speed. Initial speed is supposed to be 0. Time is 1 second and force is there. So according to the Newton's second law of motion, the rate of change of momentum is called is created by force, unbalanced force. We did it in the class also. F is equal to mvf minus mvi upon t. So we need the mass of the bullets. So what will we do first? We'll find the mass of all the 10 bullets. Because in 1 second 10 bullets are coming out. So we need to hold the gun in accordingly. So that's why I wrote there. First we'll find the total mass of the bullets and then force. Number of bullets 10. Mass of each bullet is 20. So what is the mass of 10 bullets? 200 gram. We divided by 1000, we got 0.2 kilogram. So this is the mass of 0.2 kilogram. Okay? It means 0.2 kilogram bullets are coming out in 1 second. All right. Now, according to Newton's second law of motion, unbalanced force produces the rate of change in momentum. That is, what is the momentum? What is the initial momentum of 10 bullets? MVI. M is the mass of 10 bullets multiplied the initial velocity. What is the final momentum of 10 bullets? Mass into final velocity. What is the change in momentum? MVF minus VI upon MVF minus MVI. And what is the rate of change of momentum? Rate means with respect to time. So MVF minus MVI upon T. This change in momentum is due to some force. So you can see on the screen the formula. Let's substitute the values. 0.2 multiplied by 1500 minus 0.2 multiplied by 0. The time is 1 second. 0.2 multiplied by 1500 will give you what? 300. 0.2 multiplied by 0, 0. So the answer is 300 Newton. So the force of 300 Newton is required to hold the gun in the position. Okay. So what we did in this problem, we found the mass of 10 bullets because 10 bullets are coming in 1 second, right? Then we found the change in momentum, rate of change of momentum. This is called force according to Newton's second law of motion. F is equal to mvf minus mvi upon t. Simple problem. So that's all for today's class. Changing the slide. Next, practice test of step number 3, problems. That's all. Thank you. Class is formally over.